In fact, for those of you who aren't familiar with Tango, my first introduction to it was this video. It's the first public video made available about Tango. It's 2.5 years old now, but this is the beginning that sparked my interest, and I hope it sparked yours.
My name is Johnny Lee, and I work in the Advanced Technology and Projects Group at Google. Our small team here, based in California, has been working with universities, research labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
This is going to allow people to interact with their environment in just a fundamentally different way. We can prototype in a couple hours something that would take us months or even years before, because we didn't have this technology readily available.
What happens if you have all of these pieces in a phone? How does that change what a phone is?
We have created a prototype phone containing highly customized hardware and software designed to allow the phone to track its motion in full 3D in real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation indoors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that at the moment.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Those are very high caliber people. Why? It's very simple. I think actually people believe in the vision.
Localization and mapping is there on your phone and you just use it. It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visually impaired, give them auditory cues on where they're going.
You know, being able to map your home. Oh, check out, let me see how this furniture looks in my room.
Virtual windows to sort of different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. We are just in the beginning, and we know there is a lot more work to do, but we are excited about where it is going to go. The future is awesome, and we believe we can build it faster together.
That's what originally sparked my interest, and I knew that I had to have this because it is the most accessible hardware that you can get your hands on right now. In fact, that video was released, I believe, February 2014, and before the end of that year, they released this, which is the development kit hardware. That's what we've got with us today, and let's talk a bit about what that really is. It's a 7-inch Android tablet. It's got a Tegra K1 system on chip inside it. That's a very powerful chip even by today's standards, even though this is about 3 years old in design terms. Most importantly, it has this sensor package, which really adds up to what Tango does. Because Tango is both a hardware and a software platform. There is a standard RGB camera, but it doesn't have an IR filter on it, because there is also a structured light projector. Everybody know what structured light is? Okay, would people like an explanation? If I was to stand in front of this, I am being walked. Whatever's on me is walking around me. So you can imagine if you were to cast perhaps a checkerboard pattern, the way that walked over the image in front of you is something that you can use to extrude depth. So that's structured light, effectively projecting in the IR spectrum and then using an IR camera to pick that up and a little bit of magic, and that gives you depth perception. That's a key component of the Tango core. But one of the most important things is right here in the middle. It's a wide-angle camera lens, 120, 140 degree field of view, something like that. It's grayscale, not that it matters, because that is exclusively for motion tracking. So the combination of the IR, structured light projector for depth sensing, the motion tracking camera, and a very high resolution inertial motion relay is the hardware baseline requirements for Tango. Above that, it's a sensor fusion software package. This, we've been using it for about 2 years, and it's come a hell of a long way. And in fact, it's just about ready for release. Tango is coming to consumers next month. And it looks like that. In fact, it looks like this. So, this is the Lenovo Fab 2 Pro. It contains a Qualcomm Snapdragon that has integrated timestamping support to optimize the sensor fusion. Unlike the Yellowstone, sorry, that's the code name for this tablet, unlike the Tango development kit, which uses structured light, the depth sensing on this device is done with time of flight. Most particularly, it means that it is slightly more robust in lighting conditions. That's something that I have to say, there are several caveats when using Tango, and one of them is that it is principally an indoor solution. It does not perform well outdoors, and you can imagine that because of the IR spectrum and the sun, you've got a problem. Time of flight a bit more robust. In particular, the BMD designed real 3 time of flight sensor in the Fab 2 Pro is very low power consumption. This thing actually stays on for about 12 hours. So I think it's pretty cool as a phone straight there. I'm not going to pimp this for Lenovo, but speaking from the heart, this is a powerful Android device. It's dual SIM, that sort of thing appeals to me, and it will handle micro SD card. It's got a great RGB shooter on it, and it's got a phenomenal looking screen. So even if it wasn't Tango, I'd quite like it as an Android device. But it is the consumer AR in your pocket. On that note, I know everyone thinks that VR is here and AR comes later, but AR is coming next month. And if you think about, just as a numbers game, the dominant VR platform is cardboard, because that's what people are buying. I mean, I've got all the toys, and my wife is incredibly upset about to drill holes in my living room wall to put up my 5 lighthouses and all the rest of it. And I need somebody to carry the cable around so I don't trip over. In fact, if you ask any photographer what's the best camera, they're going to tell you the one that you've got with you. And that's why I think that mobile is more important than screen door effect or optics or anything like that. That's the one thing I don't like about this, is you can't turn that off when it starts. But this is consumer AR, untethered, and it's phenomenal. And that's why I'm incredibly excited about it. I've been excited about it since the beginning, and I've done my best to try and support developers and the community. I have a developer wiki that I founded last year. It's got a lot of content for people who are trying to tackle problems. I host the weekly Tango developer meetups. If anyone's interested, you could until recently join on Hangouts, but that's been shut down, Hangouts on air, so we're moving platform, but that'll be up and running on Sunday, so maybe we can do a Hangout from here in AR. But in fact, what I must say is thanks to Google, because they're the people that have made this a reality. And in fact, I have a message that I must read out. And this is from Lorenzo Pavano on behalf of everybody at Google, and I want him to know that I said on his behalf, we're going to give a shout out to the Tango smooth operators. They make sure the whole Tango team runs smoothly. They cover everything from customer support, hardware, software, QA, data collection, documentation, logistics, events, calibration, and branding campaigns. Charlie is the team lead, automaton wizard. I don't like this. Bronwyn is the calibration master and all-round good person. Bella is the deadline maker. Tom is the data collection master with red hair. Kevin Lee is the Flash, and Lorenzo is the logistics and device manager in there. Without those people, as independent developers, we wouldn't be able to do any of this. So it's the team as well as the company at Google that make all of this possible. So shout out to them. So what is it? VIO and SLAM. Okay, so visual inertial odometry. Let's start with that. This is standard Nexus 6, and for years we've all had accelerometers and gyro packs in our phones, and people already use this sort of stuff. However, it drifts. This is the key challenge in augmented reality, is anchoring things in the real world, and drift is your enemy. And accelerometers and gyros aren't good enough to do it. I can have my phone here, I go here, I go here, I go here. They won't really know that it's in exactly the same place as it started. So how do we deal with that? Well, say I'm going to stand right here, and I'm going to walk in a circle, and I'm right here again. And the reason I could do that is because I have my eyes open. You see, the inertial part in all of us actually is your stationary fluid sloshing around in your inner ear. That's what gives you inertial perception. And that's what your IMU in your device is for. However, because I can see where I am, I can check myself. And so if I couldn't see, and I was a blind person, and I said, hey, walk in a circle and finish exactly where you started. I want you to close the loop. They can't do it. So that's why VIO, visual inertial odometry, is so important, because it allows us, using the camera, to correct the drift on our IMU. So VIO, absolutely essential. Second part of this is SLAM, simultaneous localization and mapping. And it's the idea that I've come in here for the first time, as I was saying, where are the exits? I've seen something, I've seen a landmark, and when I see it again, I can look at my motion tracking history and say, I can tell I've drifted because when I went and came back, I'm not quite where I thought I was. So the first thing is localization, that's critical. But the second part is mapping. The coolest thing about that is having some memory of it and being able to share those memories with other people. So maybe I can learn the whole of MIT's campus and just give it to you, and you'll be able to get around, even if you're visually impaired or a robot, whatever it is. So Tango is a platform for VIO and SLAM, and that's what's so important. The Tango core technologies are broken into these three pillars. So motion tracking is the VIO that we were talking about. So there's motion tracking stuff, there's some cooler stuff in the Google Play Services library for everyone to use on Android. But motion tracking in Tango terms is the real thing. And that's the first pillar of technology. The second one is area learning, and that's the SLAM component. And the third part is depth perception. Point clouds. Do you know what I'm talking about when I talk about a point cloud? Okay, so when we were talking about structured light or time of flight before, what I get back is a depth map. It's not colour, it's just depth, and that's a cloud of points. Those of you may know the word frustum. The camera basically has a cone of sight in front of it. So anyway, we get a point of clouds in front of our device. So what do we do with this stuff? And the first thing to understand in terms of the APIs is pose estimation. And this is about 6 degrees of freedom. So we're talking about the phone's here, the phone's here, the phone's here. Okay, you all know, I hope, Cartesian geometry X, Y, Z. That's 3 degrees of freedom. Am I here, here, or here? Now, while I'm here, though, I could be rotated on any of 3 axes. And so these kind of transformations, very natural, is what we do. That's 6 degrees of freedom. And so when you are using Tango, you get live pose updates. And immediately as you fire it up, if you're not using area learning or anything else like that, straight away you are able to get poses. And as you delve into the API, you'll see that from start of service, you get poses. If you're using area description files, which is where we're keeping the memories, keeping the maps of where we've been, then each time it snaps into, oh, I've seen this before, and corrects its pose, you'll see that there are ADF poses as well. So when you have a Tango application running, the service is providing you with start of service poses, and additionally, if you're using area learning, ADF poses. So that's pretty cool. We can do really stable, 6 degrees of freedom, localization and mapping. Good stuff. What happens if you put it all together? That's when it gets really cool. 3D reconstruction. So the point clouds, of course, will just thrust them in front of us. If I get a point cloud at you lads, and then another point cloud here, and another point cloud here, I check my poses, and I correct it, and I can start building up a 3D model as I walk around. Now, I'm afraid that we don't have an HDMI switch here, so this is going to be a bit awkward. Also, this is what it means to be on the bleeding edge, guys, and I will warn you up front that this is development hardware. This just turned off for no reason at all, so I'll wait for it to boot up again. Oh, thank you very much. I'll wait for that to boot up. In fact, why don't we move on? Well, in fact, before we do that, poses and point clouds. You can imagine, and I'll tell you, the sensor package on this returns up to about 20,000 points per frame, and you'll get up to 5 frames a second. You can go a bit faster than that if you want to, but to be honest, it's a huge amount of data to work with, and what you need to do is data filling. So that's all built into the Tango core, and more recently, there is meshing available inside Unity, which we'll talk about later. Wait for that to go forward. There's meshing available, which is a pretty cool thing to be able to do, and in particular, the 3D reconstruction library that's now available uses an algorithm called Chisel. It's truncated sign distance fields, for those of you who care, and that allows you to do, yep, yeah, so that's a point of note for everybody who is going to use one of these things. You'll see a whole load of Google Play Services crashes at startup and so result of that. So, Constructor. This is the implementation of the Chisel algorithm, and it is taking live poses. In fact, there's a point cloud. That's handy. So the point cloud obviously has no colour to it, but we do have a colour camera. So what we'll do is we're going to capture those point clouds and we're going to colour them by projecting the colour RGB frame onto that point cloud. In fact, it's not quite the point cloud. The Chisel algorithm is reducing the points to make this a more manageable mesh. In fact, as I walk around, I can build this up in real time. Does this make sense to everybody? We're getting the point cloud, we're transforming it by the pose, and we're degrading it into a more manageable mesh in real time using the Chisel algorithm. Any questions?
Can you output it as an OBJ or FBX file?
Yes, you can. In fact, inside the example code that you can get from GitHub, there is OBJ support. More recently, it supports textured OBJ, although previously it was color by vertex OBJ, which you will have some issues using with Blender and Unity. But you can use MeshLab to convert them into an FBX if that's what you want. So far, we have taken a bit of a mesh. There's not really much to look at here. But you can see the coarseness of this mesh. This is probably working with a voxel size of a couple of centimeters across. But I'm going to stop this recording, and, assuming it doesn't crash, we'll wait for that bar at the bottom to fill up, and it's going to do what's called Atlas texturing, because that there is the color by vertex mesh that you would get in an OBJ export first time round. But now what we're going to do, and I'm sure many of you who've done game development will know what I mean by Atlas texturing, this is now going to overlay the higher res RGB, and by the time that bar finishes, I really don't want to put this down because if I block the cameras it may crash. So I'm just going to stand here until it finishes. Any questions? Yes?
What's the effective maximum distance you would be able to capture?
Right, so the sensor package in here, and you can expect the same one on the Lenovo, works optimally at distances between 0.5 metre and 4 metres. But that assumes optimal lighting conditions. Very strong artificial lighting, outdoors, sun, anything that's got a lot of IR content is going to reduce the capability.
How would this compare to a specific dedicated photogrammetry program like Hackathon?
To be honest, it's the limitation of the sensor hardware, not software. Does that answer your question?
Does the Fab 2 have better capabilities for deployment cloud transmission as well as resolution?
That's a very good question, and one that I'll be happy to answer, although I don't know if manufacturers will be happy with that. The structured light package on the Yellowstone tablet can provide a resolution of 320 by 240 points from your point cloud. That's a theoretical maximum of about 65k points. And the Lenovo, with the real 3PMD sensor, actually returns, I think, 244 by 172. So as a hard numbers game, this is a lower res depth sensor. That's only about 30,000 points maximum. But as I mentioned before, there's data thinning happening. And so what you'll see is that you never really get more than about 20,000 points back. And I have to say that the more robust sensor package on this, I feel, provides better results. I think that they have balanced the capabilities very well. The other cool thing about that is it means that things that you write for the development kit perform effectively identically on the Lenovo. So if you get stuff up and running on the tablet, it'll work on this as well. Oh, look at that!
What's the polygons of those lines generated? Do we have hooks to play around with that?
Absolutely. So inside the API, you can control the fineness of the mesh that you want to create. And so you can take that down to, is it a centimetre? Yeah. So, but obviously your processing overhead is going to go up along with that. So you can see that this, after a bit of Atlas projection, is actually looking pretty good. However, you'll notice that there's some holes in this mesh. And anything that absorbs IR is going to be effectively transparent. Windows, water, other things are going to challenge this. So there are caveats to this technology to be aware of, but there's other things that you can do around that. So let's talk about exactly what we can do. In fact, I'm going to have to switch this back on. Which one are we? Right, so Tango APIs. The SDK is available for C, for Java, and for Unity. The libraries themselves are native libraries. They're written in C, they're optimized. And if you are NDK savvy, then you can get straight in and use the C libraries. Having said that, if you're a C developer, you'll know you're probably going to have to write your own rendering to go with it, and so on and so on. There are some demos, some examples on the official Tango GitHub, but if you're using the C API, I assume it's because you know what you're doing. Java is obviously the first-class citizen of Android programming. If that's what takes your fancy, again, you're going to have to do some of your own work to get a rendering engine up. There's a popular framework called Rajawali. I'm sure many of you who have done OpenGL programming in Android Java. The examples available on the Tango GitHub for Java make use of Rajawali, and in fact there is a complete, just as of last week, a complete example for a 3D reconstruction application, just like we've seen there, written in pure Java, hooking through to the native libraries underneath the Tango service. But I think the very fastest way to get up and running is Unity. Unity, of course, already gives you your 3D environment, all the other hooks of support, everything you find on the asset store, physics is easy, all the rest of it. So, especially because we're here at the hackathon, and I would really like everybody to have a result they're proud of by the end of Monday, we've decided to focus for the walkthrough today on the Unity API. And for that reason, we've got the unicorn himself. We've got Dylan. I must say that I'm incredibly proud to work with Dylan. I'm incredibly grateful that he is here at all. He's already shaking his head. I want everybody to know that Dylan was coming up yesterday from Florida, and he had 5 flights cancelled in a row and drove to Atlanta overnight last night in order to catch a flight to be here, and he came in just a few hours ago. Thank you, Dylan. I know that everybody's going to really appreciate what you can do for them. How are we doing today? We're not doing too bad. In fact, before I give you the floor, I'd like to show you guys some of the stuff that people have done. So, a good friend of mine, Omar Sheikh, he is from San Francisco State University, and his is the first Tango app that's being promoted on Google.com, Solar System Simulator at scale, and it is available to download from the App Store, unlike many of the apps that have been announced. Have a look. Very understandable, very educational. I like this apple. It's pretty obvious what it does. We'll move on. Sorry, Omar. Now, this is one of my favourites coming from the entertainment industry. This was a finalist in last year's Google App Developer Contest. It was one of the engineers who contributed to it. Oops, and that's not supposed to. Oh, and was winning awards this year as well. In fact, this technology is patent pending. As you might have been able to guess from this video, what this is about is perfect sound. You can't hear what's going on, can you? Right. What's going on in this is the 3D renders being constructed using the 3D reconstruction libraries we were talking about before. But perhaps, as I was suggesting to you at the very beginning, that if you can see the dimensions of the group and understand the volume that you're in, you can use that to understand the acoustics. And so this application is called Acoustic Room Calculator, and will optimize the listening environment in your space. It's a phenomenal tool. There's also an entry level game released from that same company now. Look, you can see filling the mesh. That's a useful thing to be able to do, is seal the boundaries. So young Caleb, who we can't hear, is a genius guy, doing something that I think is very important. I think it's a great app. So, this one, I think, is probably the most important for me to show you, because this is from Andrew Nakas. Andrew is one of the leading lights of our developer community. He's got tutorials, if anybody's interested in integrating Cardboard and our Daydream with this sort of stuff. He's got tutorials for integrating both the Daydream API with Tango APIs in a Unity project. You can find that in the tutorial section of our developer wiki. And this is an app he made from scratch in 2 hours. Recognize the 3D reconstruction. So it's not quite Tilt-Brush, but it's open source. And he did it in 2 hours. Any of you could do it in 2 hours. So let's see what you can do in the next 3 days. So, augmented reality. Sorry, Andrew, that's too long. And finally, this is another app that I've had the privilege of being involved with. This is a finalist in this year's App Developer Contest, the Indie Games Festival that happened 2 weeks ago. This is from Al Zubarah Labs. They're an Arab augmented reality company. They bring their unique sort of Arabian Nights flavour to what they do. This game's called AR Zombies. This year, the Play Store Indie Game Developer Festival was for any kind of app, not just a Tango app, but anything on the Play Store. And so the fact that there's a Tango app in the final, I think, is pretty kick-ass. Pretty simple. There's zombies in the real world. Don't get eaten. It'll tell you what to do. There's moving platforms and new domains really to explore. I think that where the SDK is at right now, the challenge isn't using the hardware, it's being creative with it. And this is a really good example of some of the challenges that you experience, because often when we give people a Tango app to use, they don't realise they've got to move. They sort of stand there stabbing at the screen. They don't realise that they're the controller. You're not controlling the hero in the game, you are the hero. It's a new mentality to put yourself into. So Dylan has been slaving away to prepare something that's going to kickstart all of you to get stuck into this over the next couple of days. So, Dylan, would you like to tell the guys how to do it?
Hey everyone, thanks for that warm reception earlier. I hope I can meet your I'm going to show you the link if you want to follow along. You can download the files. It's github.com/signalgarden/Tango. I'll leave that up there in a couple seconds.
Tomorrow, you'll be able to check out devices to use over the next few days. But if anybody trustworthy would like one right now,
Most people have files.
Now I have to keep tabs on this. I'm going to start at the front. That's right. These belong to Google, and Google aren't sure if they like me after I rooted the device in the first place. So, please, don't steal these.
Okay, I do want to say, if you want to go ahead of me, might go slow for anybody that doesn't know Unity. The Word document or PowerPoint is in the folder that you may have downloaded. Feel free to do that. I do want to say these instructions are not meant to be like a dissertation or anything on how Tango works. I leave that up to Chuck and the theory and everything. It's really meant to give you the raw steps to get started with Unity and Tango, and also hopefully elicit or motivate you to ask some questions. We're definitely here to answer questions. If not, make your mind. Before I get started, I'm going to try to go through this tutorial with you in Unity as soon as these Tangos are passed up. They're going to need ports too, right?
Hope everyone's got micro USB cable.
We have over here.
No, I think that's just chargers.
Okay, I've got the little pack.
I have a particular set of skills.
That's why you know the fire escape.
I will find you.
Yeah, you want the link again?
No, I have it.
Okay.
So the document is
It should be in the folder. Yeah.
I got started when it was
Oh, I don't remember.
It was when you were there.
Yeah, okay.
Let's see, I have an idea. Can you make it so that it just goes behind something?
Like occlusion in AI?
Yeah.
This will show you one method of it. There's another way to do it. The Tango core has a very crude way of doing it also. This way is slightly better, but I'm not going to say it's good. But we will touch that a little bit.
So if we do that,
well, so the way the Tango core does it is it uses the point cloud and it uses a special shader on the points. It basically updates a mesh with those points, and the shader essentially clips anything behind it in the game. This way, we'll be using 3D reconstruction to basically provide the inclusion of group. But you'll see that the 3D reconstruction isn't 100% accurate. Yeah, another problem with point cloud is that it's the field of view of the point cloud. It's not necessarily the field of view of the RGB camera. So that you may need, the edge of the screen might not be included because of the point cloud.
How do you enable either one of those two techniques?
The first one is just a checkbox. We will put it in one of their Unity scripts, and I'll show that to you. I guess that would be shown to you in practice. Yeah, it's not. Yeah,
Let's do that.
Yeah, the second we will actually do them.
So that's as many as we've got that are powering up. They're distributed. They mustn't leave the room, guys. Do the right thing. The other thing that mustn't leave this room is the super secret Google security code that will get you into them, which is 5555.
So, we'll get started unless somebody wants some more time or they're having trouble downloading anything. Okay, good. So, first step is really tough. Create a new Unity project. Name it Tango Workshop. I'm going to do that right now. Okay, for any Android developers or anybody that attended Lex's workshop earlier, you'll recognize changing the bundle identifier. First go to File, Build Settings, and change your platform to Android. Once you do that, click on Player Settings. And on the right side in the inspector here, includes Other Settings. And you want to change this bundle identifier. If you leave this bundle identifier the way it is, you'll get a build error when you try to build this app. Oh, I'm sorry, thanks. Where are you at? So to get to the bundle identifier, first you go to File, Build Settings, and you need to switch your platform to Android, because Android is the platform that has bundle identifiers. Then you go to Player Settings, it'll open up this inspector on the right, and in Other Settings you will see bundle identifier. You can change it to whatever you want, as long as it's not the default, it should work. The instructions give com.tangoworkshop.example. Okay, once we're done that, we're going to import 2 custom packages. It's fine. It should be fine how it's set. Chuck, can you?
19 is the daydream, 17.
I know KitKat is what it's supposed to be. Let me check it again after you import the package. Because I didn't have any issue building it without doing it. I know you are right. What you're saying is correct. So the next step is to import 2 custom packages. And they'll be in that folder that you downloaded. And the first one is the Tango core. Which is the Wasat release. I don't know what I'm pronouncing. And this is a huge package. It might take a little while. Don't worry about it yet. If it's an issue, we'll handle it later. Just leave it as default. Yes, import the entire package. Once that's done, import the second package. Yeah. Mobile mesh. It doesn't like mesh. That's a custom package. I mean, just for this.
So we import both of them?
Yes. Yeah.
What was that name like?
For the second package? Let me get that. Tango Workshop _ MIT. This is the second package. That one will be much faster. It's just a couple of prefabs, 2 scripts, just to get us started. We'll be extending the scripts later, but it's just so we're not sitting here for 2 hours getting started. I tried to write through the different comments so that if you guys are interested in how it works, if you're new to Unity, you can look at it as an example. Okay, so once you have the 2 packages, you're going to delete the main camera in your default scene. Sorry, it's in the scene hierarchy. You'll see main camera, you'll see a directional light. So once you delete your camera, your preview, not like you, your game preview. And then we're going to start adding some of the Tango components. The first one is under Assets, Tango Prefabs. There's a prefab called Tango Manager. So under my Assets, Tango Prefabs, Tango Manager. Just drag and drop that into your scene. There's a couple of options we need to change on this. We need to enable depth. So when you drag it, you see it's opening in the inspector. We need to check on enable depth, enable video overlay. We want the method for this video overlay to be texture and raw bytes. We want to enable 3D reconstruction.
Speak up, Brandon.
Okay, thanks. So once you enable 3D reconstruction on the Tango Manager prefab, you want to bring the, and this is, somebody asked a question about changing the resolution of the generated reconstruction. This is where you do it. The resolution in meters. By default, is a 1/10 of a meter. Google, I believe Google claims the Yellowstone is accurate up to a centimeter. So you can go to 0.01, just understand that this can be very, very slow. And you don't necessarily, you need to think of a trade-off between performance and quality. A good one for this tutorial should be 0.05. And right beneath that, we also want to check on generate color. Okay, so that's all we need to do with the Tango Manager prefab. Does anybody have any questions about that? No? Okay. We're going to move on to the next prefab, which is the Tango Delta camera. It should be in the same folder as the Tango Manager. So just drag and drop that into your scene as well. And on that Tango Delta camera, there's a default character controller that we do not want right now. So check that off in the inspector. You can even remove it if you want. Okay. Now in our scene hierarchy, you can see on the screen here on the top left, I'm going to click on Create. I'm going to create empty and name it Dynamic Mesh. This is what's going to hold the reconstruction of the world in our scene. We're going to add a couple components to this. First being assets, Tango SDK, examples, experimental mesh builder with color, scripts, and the only script in that folder. You can drag and drop that onto the dynamic mesh object in your scene hierarchy. So when you're viewing the dynamic mesh in your hierarchy, you should see the script in the inspector. Leave that option on, so you know. This is going to hold the yes, yeah, create empty, just rename it. Sorry, did I write that wrong? Oh yeah, I am so sorry. Thank you for that. This is not the script that you want. So anyone that listened to me, that was wrong. And he's paying attention. Go on to common. It's under Tango SDK, examples, common, scripts. And you want the Tango dynamic mesh so that it even makes more sense. It is, yeah, assets, Tango SDK, examples, common, scripts, Tango dynamic mesh. The component will look like that. Two booleans, two checkboxes. Next, click on Add Component to that same object. Go to Mesh and add a mesh renderer. We need that to actually show the vertices, faces. On that mesh renderer that you just added, expand the materials and element 0. Change it to, make sure I'm doing the things right, unlit vertex color. It should be near the bottom of the list. So your dynamic mesh object should have two components, a Tango dynamic mesh script and a mesh renderer, whose only material is called unlit vertex color. We're very close to making our first build. All right, still that same object. We want to add one more component. Add component, physics, mesh collider. So once you're done with your dynamic mesh, it'll look like this in the inspector on the right side of the screen. Next, we're going to create another empty game object. We're going to name that GUI. And here is the script that I was thinking about earlier. So to your GUI game object, you want to add Tango SDK, examples, experimental mesh builder with color, scripts, mesh builder with color GUI controller. We're about 30 seconds from building our first build. What's that? Number 9. No, this is one that comes with Okay, just a few more steps. Right now our gravity is really, it's accurate, but it's too much for what we want right now. So we want to go to Edit, Project Settings, Physics, and we want to decrease the intensity of the gravity. -1 should be fine. Talking about the gravity? Up at the top of the screen, go to Edit, Project Settings, and go to Physics. And in the inspector, you'll see that the top property is gravity. What was that? Oh, you got it? Okay. So, anybody that's already had and built this thing, it's a little crude. You might not like it at first, but it's going to get a lot better much faster. It is pretty cool. If it's your first time, yeah, I might not be doing it justice, but it's going to be a lot cooler once we're through a few more steps.
So, has anybody successfully built it?
Yeah.
Anybody else? Do you want to push it and show off further?
I need to do one more thing. Okay, so last step for this section is we're going to go into an asset that I've created under Tango Workshop, prefabs, drag the game manager into your scene. Okay. Now you can save your scene. Name it whatever you want it to be. Okay. And now we're going to build. We go to File, Build Settings. It might be back on PC. It doesn't for me. I don't know if it will do it for you. So switch back to Android and hit Build and Run. And just write a name for the APK. For anybody that's not familiar with Android, if you're familiar with executable files.exe, you can think, it's not a great analogy, but you can think of APKs as what an exe is on Android. It's a program. So you just say you're creating a file name for your app on Android by naming this APK. If you have a tablet plugged in, it should automatically detect it through USB, and it will try to deploy it. If you did not change the bundle identifier, you will get an error. I'll try this. Yeah, sure. Page 2. Right here? Yeah. Wow, I do not have the Android SDK. I'm all messed up. Hopefully you guys have the Android SDK installed. Unlike me. I will show you a video I already have of this. In the folder that you downloaded, there's a screenshot and a video of each breakpoint in the tutorial, basically. These lines, the italic light blue lines, have an accompanying screenshot and video of what it should look like. So here's a screenshot of what you should get once you build it. Oh yeah, yeah. Would you mind putting it? Thanks.
This is how we should be. You're the ones supposed to do it. So Caitlin's built this already. So what's going on there, and why is it moving in 3D space?
You talking about the camera?
The target.
Okay, so the target, this is part of the game manager prefab that I created for you. And you can look through the code for exactly why it's doing that, but essentially it's assuming that you're aiming with the middle of the screen. And if there's reconstruction data there, it will show that little blue target to allow you to put a cube or a ball. And I can show you how to create your own shapes in about 2 minutes if anybody's interested. Nobody's interested. Oh, you are? Okay. Okay. So I'm gonna thank you for showing that. It doesn't necessarily, Chuck. It doesn't necessarily say the reconstruction unless you ask it to, right?
That's right. Yeah. In fact, where it's being held in Unity by default is inside the Unity mesh. And so you export that anywhere you like. And as I said before, there is OBJ export already provided as convenient as necessary.
So we're not going over any exporting here in this tutorial, but if you like, I know Chuck has a million resources on how to do that. He literally has an app right now that does it on the Play Store. It's the only app, it's the best app. Is to fix
the highest downloaded third-party app.
It works when Google's own apps didn't work. Okay, so I'm going to show you how to create a new shape. Under Tango Workshop, prefabs, shapes, you can see there's a cube and a sphere prefab. If anybody's not familiar with Unity, these little blue cubes, that identifies a prefab. And a prefab is how do I describe a prefab? It's an object it's a blueprint for an object. It's not just a primitive, it's something that you set up beforehand. I'm not sure if that's the best explanation. But this is a very easy process to make your own. So if you want to make your own shape, select one of these, doesn't matter. Hit Control-D to duplicate it, and you can rename it if you like. And there's really only one thing that you need to change on the mesh filter component of your new shape. Change the mesh. I'll change mine to capsule. Now, if you want the physics to be accurate, you also need to replace the collider. I'll leave that up to you if you want to. I'll replace this with a capsule collider. So it's accurate. Okay, so you have your new shape prefab. The last thing you need to do is select the game manager in the scene hierarchy, and you'll see on the game manager component, there's a drop down for shape prefabs. Just drag and drop your new shape onto that drop down, and you'll see it gets added as element 2. And since I don't have the Android SDK, I can't build, but I can show you the editor. So maximize. All right, so the game manager automatically creates a button for you to throw your new shape. And if there was any reconstruction data, we would also be able to place your new shape. There's my capsule. So you can have fun messing around with that.
It's a point of note for anybody who'd like to get up and running before they get their hands on the device for 3 days starting tomorrow. That there is an emulator inside the support package for Unity, and it will start up by default with the phone that you can see the one cloud and so on. So you can get up and running and build stuff before you want to.
Okay, so that's it for the first part. If we're ready, we're going to move on to the second part. It's going to get pretty cool. Hopefully fast. Oh, that's what you build. Try to okay. It should have the default Unity, so it should have. Okay, so moving on to part 2. What they do? Yeah. Do you have any specific questions, or you just like how does this all fit in? Okay, so any Tango application you create with Unity is going to have a Tango manager, unless you create your own Tango application script. This is basically the hub of Tango activity, and that is why there are so many options in that component, as you can see in the screen here. It controls all 3 technologies that are crucial to Tango. You can see motion tracking, area descriptions, depth. 3D reconstruction is obviously very important, and they're always adding options to this. They recently added the update method between projected and translation, I believe. Translate? Traversal? I think. Chuck, can you talk about the difference between projective and traversal?
I can do. Give me 30 seconds.
I'll leave it there.
If you can.
Yes. That was the game manager. If you have any files, you can open it up. I try to document it really well once I actually go through. And basically, there's a loop that goes over prefabs associated to that list of prefabs, and for each one, it creates a button. What is the difference between the 2 update methods of 3D reconstruction, projective and traversal?
Oh, God. It's in the docs. We only use one. I think it's traversal.
The default is projective.
It's a chip. I'd have to look it up, and you could do that yourselves.
Okay, yeah, so best answer, we don't have an answer. This stuff is very new. As I said, this update method is extremely new. I think it was just before Masad, right? We have some ideas, but they're just ideas.
The way that the chisel algorithm works, if you want to do the doing 3D reconstruction is potentially infinite. How long are you going to wander around building a mesh? And so obviously memory management is an issue. So what happens with chisel algorithm is that the world is segmented into blocks, let's call them 1 meter cubed. And as you move from one block into a new block, memory is allocated to that. So you start stacking up blocks like that. As you go back over regions that you scanned previously, they can update. The update method is to do with that.
Okay, so to keep answering your question, that's the thing. So the Tango Manager is going to be in anything that you create in Unity for Tango, unless you get deep enough to start not using their. Our team specifically has found that the best approach to creating Tango apps really is to not use Google's strategy. Because they're really, I don't want to do Google as a service, they're intended as a starter. They're not necessarily intended to be used. They're examples, essentially. And they are
starter code, it's not supposed to be examples of best in class practices.
And that said, they are very good examples. If you look through it, they're very well documented. They do break a lot. Sometimes we won't take the newest update because other people tell us that it breaks, and we test it, and it doesn't break what we have. But yeah, you can't fault Google for that. But okay, so Tango Manager, the dynamics that Tango Delta camera. This is correct me if I'm wrong. Tango Delta camera is essentially if you just want a camera that moves with the device. They have different prefabs for different cameras. Like the very first step in part 2 is we're going to delete this and add an AR camera. Really, the only difference between those is that the AR camera's video feed.
This is what I'm looking forward to. Yeah.
Is that right?
So far, we've been doing 3D reconstruction, we've been talking about all this cool stuff, but as is apparent from Pokemon Go, simply having a couple of background cameras in your app is enough to convince people that it's augmented reality. But Pikachu doesn't stick to the floor, and if I look behind the table, he's not occluded, and so on and so on. So, take it away, Dylan, it's now going to be a problem.
Do you have any questions about the game manager? Okay. Well, I do want to say something about. Well, how many? By show of hands, like how many people here would say they're familiar with Unity development? Is it a lot of people? Okay, it's about half, maybe not even. I want to say the reason the game manager is there. And this is sort of into the design of Unity. If you think of a script or a piece of code doing one specific thing, that's sort of the way Unity, if you look at the Unity documents, that's how they approach game development. So I have the game manager as doing one specific thing. It's managing the game. And yes, that is a little vague and it is a bit of a wide range of things. But it's not like you try to have. Let's see if I can get a better example.
That was a particular question.
So just trying. Well, there was a question about why certain things in this environment. I guess it's not that important, but I will say. The two scripts that I wrote for this tutorial, the one is game manager, the other is a shape controller. And every shape that you throw or place has a shape controller attached. So there is certainly a way for me to have the shape controller and the game manager as one script, but it's not very conducive to managing and understanding how this works. It helps me rationalize this stuff in my head to have two separate scripts. One script handles shapes. The other handles the game in general.
And all of you pro developers should understand the trade-off between company
and I know that's not a great explanation, but I'll just leave it at that. Okay, so part 2. First thing we're going to do is delete the Tango Delta camera. And we're going to get that screen again saying we're not doing this. We're going to drop in the Tango AR camera from the Assets Tango prefabs. Okay, and on that Tango AR camera, you're going to see a camera component in the inspector. And about halfway down, you're going to see clipping planes. And by default, Google has this pretty close at 4 meters. It goes hand in hand with the answer Chuck gave about how far the point cloud goes. It's about 4 meters. But right now, we're not necessarily depending on the point cloud, so we want it a little farther. I'm going to put it at 10. You can put it higher if you like. Okay. So with that, you save to build and run. Does everybody already have this? You should have something that looks like this. You're going to see exactly your reconstruction again, but behind it is just the video feed of your camera. And you can see that the reconstruction isn't nearly as nice.
See how accurate.
So what we're going to do next is sort of forego the coloring that the reconstruction does, and we're just going to use the video to replace it. So, first step, Tango Manager, we don't need it to generate color anymore, so we're going to uncheck that.
Sorry.
And then under Assets, Tango Workshop, Textures. You can right-click inside the folder and go to Create, Render Texture. Anybody not familiar with render textures, this is a special texture in Unity that is designed for different things, but mainly to receive the image drawn by a camera. So if you have a camera that you don't want to be drawn to the screen, but say you want it in a texture, like say a TV screen in a game might have a render texture because it's a rendering view of another camera inside the game. And we're going to name that render texture Video RGB Texture. Make sure its size is pretty large. The resolution size of these tablets is 1920 by 1200. So I'm just going to set that to make sure it's not degraded at all. And now selecting the Tango AR camera in our scene hierarchy, we're going to go over to the inspector. You might have to scroll down to see it, but there's a Tango AR screen script attached over here. Now generally, when we're working on our apps, I do not modify Google scripts. It's just not good when you're updating. You install a new package and then all your work is gone. But in this case, we're going to do that because there are a lot of dependencies on Tango AR camera that would take us a very long time to replicate. So we're just, it's only a couple lines, and it'll get the point across. So what we're going to do is this Tango AR screen script on the Tango AR camera. We're going to select this little settings icon and edit script. Okay, you can see right away that Google has a lot of helpful documentation in the script itself. On line 37, we're going to create a reference to a render texture. And we're going to call that Video RGB. Okay, so line 37, public render texture, Video RGB. Okay. Don't worry about understanding this. If you don't understand, if you don't know C#, there's not going to be a whole lot of C#, at least in this step. There will be more in the later steps. But the course, the point of this workshop is not to teach you C#. Okay, so scrolling down in that same script, we're going to find a method called public void start. So for me, it's on line 113. If you add 2 lines, you should have it on the same line. And scroll down a little bit further, and you see some lines about command buffers. And what we want to do, you can see these 2 lines. m_camera.add command buffer. There's 2 of those method calls. We want to insert our own code in between those 2. So after the first, but before the second, we want our own code. And what it's going to say is if video RGB so we're creating an if statement. And open curly braces. And we're going to create our own command buffer. Call it extract. So we're creating our own command buffer called extract, and we're constructing a new command buffer. On the next line, we want to add a command to this command buffer, and it's going to be blit. And so I'm fairly new to blitting and this sort of graphics. Chuck might be able to chime in here, but I will say basically what this is going to do is it's going to take what this camera is drawing to the screen and it's going to copy it into something else. And that something else is going to be our render texture. Sure, I do this right. So we're going to pass a null for the first argument, which is the source. We don't want a source in this case. But our destination is our render texture called video RGB. So this is the first part of our new command buffer, extract.blit. If you pass just null in this first argument, you might get a vague or indeterminate. I forget what the term is, but it doesn't know what kind of null you want. So because there's an overload for this method, it can be either a texture or a render texture, I believe. So just tell it either one. I chose texture, a texture null. And the second argument is our render texture. Okay, so the second command for our command buffer is that once so this right here, this blit, as I just said, is copying the AR camera video feed into our render texture. Once we've done that, we want to clear our camera, because otherwise we have 2 copies of the video camera. And I don't know why I wrote that. Extract dot clear render target. We're going to say true color dot black. I'll explain this in a second. If you look at the IntelliSense, I know this is too small to see, but it says it has 3 arguments: clear depth, clear color, and the color that you're clearing it with. So the first 2 are booleans, which is just true or false. Yes, we do want to clear the depth. Yes, we do want to clear the color. And black is the color that we are clearing it with. So what this is doing is whatever is being drawn by the AR camera, we're wiping it out with the color black. That's what we're doing. And just like the other two method calls, in camera add command buffer, we're going to add our own command buffer. In camera add command buffer, camera event, before forward opaque. So all I'm going to say about this is that when objects get rendered to the screen, there is a certain order that has to be done, otherwise it just won't look right. And this is the specific location, the specific time in the rendering of this camera that we want this command to be executed. Rendering engines is a whole rabbit hole. There's definitely not within the scope of this workshop. And the second argument is our actual command called extract. Okay, so this is all the code for the second part right here. Does anybody have any questions or having trouble with this code? Is it right so far? We're about to test it. Alright. So go ahead and save the changes. We go back to the editor. And once it updates, Unity will automatically update your changes. Once it updates, you'll see a new property on your Tango AR screen. It is the render texture that you created, the reference one that you created in the script. And go ahead and change that to the render texture that we created earlier. It's called video RGB texture. Does everybody see how I did that? Just click on, it was a reference to null, or nothing. It says none, render texture is what it's supposed to be. Click the circle and select the render texture that we had created previously. Yeah. The Tango AR screen script. Oh, I'm sorry. The Tango AR camera. Yeah. Okay. Once that is set, select the video RGB texture, render texture that you created earlier. And you should get a little preview of what that looks like. It should look black because we haven't drawn anything into it. It's a black texture. But once we play, it's might be hard to see in this flash. I know this is real small, but right here you're going to see what the camera is supposed to be drawing, but it's actually being drawn into the render texture. And the reason it's so small is because the actual resolution of the editor right now is that resolution. Once it's running on the tablet, it will actually take up this entire render texture. And so, this is a good time to show off what Chuck was talking about, the built-in emulation of Tango. If we don't set this render texture, the AR camera will give you an emulated scene so that you don't have to build to your Tango device to test point cloud logic or anything like that. This is the emulated scene. So when we have that render texture set, this is what's being drawn to the render texture instead of the camera.
How's everybody doing?
I know it's getting towards the end. I think what we were going to write a shader, but it's already completed in the package, so I think we're just going to put that up so you can see the result very quickly.
Is anybody struggling? Those who are
Yeah.
working a lot. What's that?
Okay, it should be. Okay, did you import this in package? This is trying to access and import custom packages, right? Import packages.
Those of you who are leaving, can you alert me if you've got a Tango? Don't you sit it on the chair?
Then once you import it, so we have a folder called Tango Workshop, refab. Okay, we're going to fast forward a little bit so we can get you this next result before time's up. So, under Tango Workshop, materials, we're going to create a new, actually, this is already created. No, we'll go ahead and do it. Create material and call it AR projection. Once you create the material, you'll see the new material in the inspector on the right. And at the top of that inspector, you'll see a shader dropdown. And I've already written the shader for you. You go under Tango Workshop, completed AR projection. There's one property for this. It is a texture. And we are going to select our render texture, which we call video RGB texture. Does that make sense? Anybody need that again? Okay. Now on the dynamic mesh, remember we changed its only material to unlit vertex color. We're going to switch that to our new material, AR projection. Okay. And now, you should be able to build and run and see something similar to this. Sorry about that. So now you get the 3D reconstruction, but it is not getting colored by the Tango API. It is being colored by the camera's video RGB texture. So it is much more accurate to what the user is actually seeing. If anybody has this working, I'd love to hook it up to the projector.
So you were talking, so when it went over a rock, it actually changed to the wide direction.
Yeah, because the shapes have sliders attached to them as well.
So, the target as the block is in the way, the target behind you.
I created that was an issue that was kind of interesting. One of the things the shape controller does is that if the velocity of the shape is too high, it will ignore raycasts. And raycasting is how I position that marker. So if it ignores raycasting, it just passes through. That's how it works.
Here we go. Let's try that.
Okay.
So this was all your instructions?
Yeah, it actually goes farther. I was hoping to go even further, but the hurricane magnitude.
So, Caitlin has completed it. Let's see what happens. Fresh build.
You're going to ask something.
Oh yeah. All right. There's a tip. Look at that. I can even put your logo on it. Right. Thank you very much.
Okay, so the next part would be adding lights that realistically affect the environment, which is pretty cool. Do we want to go there? Can we go over? I don't know how this works. I guess we can, right? Is there thinner?
Oh wow, now.
Well, if you download it, you can follow along the instructions. Say yeah. It goes It goes through lighting and using a point cloud to determine if something's involved. It's a very basic element.
You gonna post this?
But it does give a basic implementation of the point cloud to get that. That's about where it stops.
That's what you need to know. So we'll be happy to do this as long as it takes, but we're here, Dylan and I, until the end of this on Monday, and we're here to help. We didn't realise that dinner was the thing, so sorry. We would like you all to go hungry. You can download all of this from github.com/signalgarden. As we're running out of time, I ought to give props to everybody at Signal Garden. It's not just yourself and Dylan. There's great things. We're always looking to incubate. We're always looking to hire.
If you want to see the tutorial is not finished, if you want to see it finished, find us on Google Plus Tango Developer Group and just let me know. If you like it, I will spend the time to finish it. I was planning to add some artificial intelligence and a dartboard game. It will show you how to place a dartboard, but it doesn't have the game attached. And if you want to see more, just let me know. Yes?
How long will you like when you wind up with Mosey on your street?
I just started yeah, and like Chuck was saying, it's not so much the basics of how do you want the creativity?